Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question 12 on our 2017 Part 1 of the Alberta Math Contest. And let A and B be positive integers. The number of quadratic equations, x squared minus ax minus b equals 0, having the positive root less than 10 is... Okay. So they're pretty confident we're going to get positive roots, and that should make sense. Because a and b are both positive integers, so this is something like x squared minus 2x minus 3. And remember, the product of your roots is the last number here, when the leading coefficient is 1. And it's a negative number, so if I had two positive roots or two negative roots, you'd get a positive number here. We must have a positive and a negative root to get a negative b here. Okay? But these roots also add to negative a. So they add to a negative number as well. So here's something we could do. We could say, maybe one of the roots is p, one of the roots is q. One of them's positive. Let's let p be the positive one. We'll let q be a negative value. Well, no, so roots are p, positive, and we'll say negative q. So both p and q here are negative. So then you'll get minus, so p has to be greater than q. I think that's what we're looking at here. And then minus pq. All right, there we go. So b is pq, a is p minus q, which is positive. So p is greater than q in terms of positive values, but p is also not bigger than 10. Okay. Now, we've got a handle on the sort of root situation, I guess. P and Q are both positive. Minus Q is one of the roots, not Q. But what are they asking for? They're asking me to count the number of quadratic equations, and just looking at the possibility, this is a large number of things. Now, 441 catches my eye because it's a perfect square. But what else can we do here? Well, I suppose we could express our solutions, our p and q, in terms of the quadratic formula. So our roots are negative b, which is technically just positive a, plus or minus b squared minus 4ac. Write this all correctly first. And so a plus or minus square root of a squared plus 4b all over 2. Okay. Now, one thing I'm tempted to do, multiplying and dividing my roots by 2 doesn't actually change whether they're positive or negative. It would just make my roots have to be at most 20. But that might be something I'm willing to work with. Okay. So the roots are a minus square root of a squared plus 4b all over 2, which will have to be negative. And a plus a squared plus 4b. Because 4 is positive, because b is positive, 4b is positive. So whatever value is in here is greater than a squared. So its square root is greater than a. So you're doing a minus something bigger than a. So this will be positive, but we also want it to be at most 10. So I think just multiply both sides by 2, and you'll get a plus the square root of a squared plus 4b has to be, is it at most 20, or So less than, so it's got to be less than, so it's a less than sign. I think that's all we really need, is to find the pairs A, B that satisfy this. So what can we do? Well, I suppose I could subtract A from both sides, and then square both sides. Now, I'm a little wary to do that, just because squaring inequalities can be not the most pleasant thing. But we'll get 40a and then a squared. So now the a squareds go away. So 4b is at most 400 minus 40a. Divide by 4. B is at most 100 minus 10a. Now, will any of these work? Or sorry, will all of these work? All right, so for example, if I let A be 1, B could be at most 89. Will that give me something? X squared minus x minus 89 equals 0? What roots will I get there? I'll get A plus or minus 1 squared times 4 times 89 all over 2, and I should get roots there. Well, I will get roots. Just a question of, do they have the right size, or has something gone wrong? And it's always good to do a sanity check like this. So you get 1 plus or minus the square root. It's about 18.8. So if I add 1, divide by 2, it's just under 10. So it'd be 9.947. All right, so this looks good. And I suppose the easiest thing to do is probably just make a little chart. So A, maybe 10A, maybe 100 minus 10A, and then my number of B's. So if A is 1, we get 10, 90. So the most B could be any number between 1 and 89. 2, you get 20, 80. So at most you could have 79. And you can see you get 69, 59, 49, 39, 29, 19. When this is 20, so this is 80, so 8 is A. So you'll get 9, and so A could be 9, B could be at most 9. And if A is 10, then B would have to be negative, so it can't do that. So it looks like I just need to add up these numbers here. But again, you might want to do, a sanity check. X squared minus 9x plus, or minus 9. Do we get roots there? Or if it's minus 1? I checked the biggest B can be for a given A. What about the smallest? So, we'll do a quick check with those. 9 plus or minus 81 plus 4 times 9 all over 2. 9 plus 81 plus 4 times 1 all over 2. So if this one works, this one should work. But just check 81 plus 36. Square root, so it's square root of 117 is about 10.9 or 10.8 plus a 9 divide by 2. Yeah, it all still works, 9.9. And of course, 81 plus 4, it's going to be even smaller, so that'll work out just fine. Okay, so we just need to do 89 plus 79 all the way down to 9. So how many of them are there? 0, 1, 2, so there should be 9 of them. Actually, here's what we can do. We can just say that this is 90 minus 1, 80 minus 1, 70 minus 1, 10 minus 1. So how many of them? Well, we're minusing 9 of them. How do you add up these? Well, this is 10 times the sum of the numbers from 1 to 9, which is 45. So we'll get 450 minus 9, which is 441. So it turns out 441 here is the answer, but not because it's a square. At least maybe there's a way to do this question where it's obvious it's a square, but just sort of coincidentally. There we go. C should be our answer. And I'm happy with that, so I'm ready to move right along to question number 13, and we'll take a gander at that next time. So thank you guys for watching. If you'd like to be kept up to date, feel free to subscribe to the channel. If you like what you see so far with our Alberta papers, feel free to like. And if you ever have a different way to do the question, if you have a different explanation as to why this is 441, maybe using the fact that it's 21 squared, I would absolutely love to see it, and you can leave a comment down below. But other than that, I'll let you get back to more math, and I'll see you for more math next time.